Welcome to, I guess I can call this part 2 of logarithms and their graphs. This was just an omission on my part. The first video had page 1 and page 3 of the notes, but I had misplaced page 2, so I'm going to fill in with page 2 here. Not too much going on. In fact, the first couple problems are going to take longer than maybe the rest. First thing is, we could graph this by hand, and I've got a whole separate video just of graphing logarithmic functions by hand, and we had a worksheet that associates to it. But here they want us to actually use our graphing calculator to graph this, and they suggest graphing it this way. This would be y equals change of base ln x plus 2 divided by ln 1/3, and that will work. That's our change of base. Now, we could do it that way. As an option, I'm going to blur this down just a little bit. As an option, just trying to get a good compromise of shading here where we can see everything. There we go. If I go, let's see, second quit, clear this. And clear this. If I go math alpha math, which is really math alpha A, math alpha, and back to math, that gives me log, and I can choose my own base. So I could actually put in base 1/3 here. So we could do that. Or we could do the change of base. I don't care so long as you can get it done on your graphing calculator. So we could also graph this thing as, I'm going to go back and forth a little bit here. We could also just graph this as it appears, log base 1/3 of x plus 2. And I'm going to do it that way. But the ln x plus 2 on ln 1/3 change of base formula will give us the exact same graph. Okay, so I'm going to go back onto here, try to get that good compromise again where I can see everything. Not too bad. And I'm going to go to y equals, and I'm going to do the math alpha math. Log base 1/3, step out of there, of x plus 2, and I'm going to go into zoom 6, zoom standard. And I'm going to look for some just good solid points to transfer here. So I'm going to go second calc value, and it appears like maybe -1 is right on 0. So I'm going to check that. -1, yep, that's 0. And it appears like possibly 1, I don't know what 0 is. Let's check what 1 is. Yep, 1 is at -1. And then nothing looks really good until, let's see, 2, 3, 4, I don't know. Let's just move across and see if we get any good values. 4, nope. 5, nope. 6, nope. Well, maybe we won't get any. 7, oh, there's one. 7 is -2. So 7 is -2. That's 1, 2, 3, 4, 5, 6, 7 is -2. How convenient. And then we gotta be smarter than our calculator. I'm still in calc value. I'm gonna go -1.999. And at -1.999, the graph says it still exists even though it doesn't show it did. The graph just takes steps. It creates dots and then it connects the dots. It must have stepped over our asymptote here, but the graph definitely exists there. How about -1.99999? And there we are. We'd be up at 10. It exists. But if I go to -2, the graph ceases to exist. And on inspection, I think that becomes pretty clear why. There is no exponent that will turn 1/3 into 0. Therefore, x may not be -2, and -2 is an asymptote. So just graphing this with our calculator, we still got to be smarter than our calculator to know that graph doesn't just materialize in the middle of nowhere. We look something like that. Okay. All right, let's jump to 38. Use the properties of logarithms to rewrite and simplify the logarithm. Well, my hope is that 243 divides by 9, and 2 plus 4 is 6, and 6 plus 3 is 9, so our divisibility test tells us it will. I'm going to write that well over here. 243 is 9 times, let's see, 9 goes in twice, that's 18, 63 goes in 27 times, and that is another 9 times 3, so I could think of this as log base 9 of 9 squared times 3. And our properties that we went through in class yesterday, you have the if you saw the first video, you saw those. We can take log of a product into log of the first factor plus log of the second factor. This could be log base 9 of 9 squared plus log base 9 of 3. But I'm going to change 3 into square root of 9 to get some compliance here. So this is the exponent. This whole thing is the exponent that would turn 9 into 9 squared. Oh, that's 2. And this is the exponent. Here's my little thought bubble here. This guy is really log base 9 of 9 to the 1/2. That's a square root. This is the exponent that turns 9 into 9 to the 1/2. So that's a 1/2, and we end up with 2.5. So kind of slick there. All right, here we've got log base 3 of 9. I like it with the 9. Times, I can split it into addition, log base 3 of 2, 4. So I'm going to go log base 3, but rather than 9 here, I'm going to represent the 9 as 3 squared. There's my 9 squared, plus log base 3 of 2 to the 4th. Not crazy about that 2. So this is log base 3 of 3 to the 4th plus maybe 4 log base 3 of 2. Just pull that 4 out. You could also make this 16 inside of here. This is the exponent that turns 3 into 3 to the 4th. This is just 4 and plus 4 log base 3 of 2. Okay. ln. Rule 1, I got a product. That can be ln 8 plus ln e to the 3rd. I'm going to put a sneaky hidden e, the sneaky hidden e here. ln 8, not so sure. What is the exponent that turns e into 8? I don't know. But what is the exponent that turns e into e to the 3rd is 3. 44. ln e to the 5th on 7. Division by rule number 2, we can turn that into ln e to the 5th minus ln 7. This is the exponent that turns e into e to the 5th. This is 5 minus ln 7. Okay. Now we're supposed to, for 45, 46, it's just a proof. We're supposed to prove this equals this, and my choices would be to break this up into terms of 2 and 3, or to smash this thing together into a single logarithm. What I like about this is the negative. Not going to mess with the negative. I'm going to bring the 3 in with a rule 3 in reverse, ln 2 to the 3rd plus ln 3. I'm not going to mess with the negative. Rule 1, I can smash this together in ln 2 to the 3rd times 3. That's equal to the opposite of ln 2 to the 3rd is 8 times 3. And we got it. Equals negative ln 8 times 3, 24. Okay. Challenge yourself. Just turn the 24 into terms of 2's and 3's and you got it. This would be 2 to the 3rd times 3, and we see where we got it. 2 to the 3rd times the 3. Okay. All right, and expanding. So here we want to get multiple logarithms, and I'm going to state that we want to have the argument of the multiple logarithms as simplified as possible. In this case, pretty straightforward. Log 7 minus, this is a rule 2, log z. Now, you don't have to have the tens down here. This is called common logarithm. If there's not a number underneath log, not a subtext, then it's just base 10. But you can put the 10s there. Okay, 60's got a little bit more going on. We like exponents rather than radicals in logarithms. So this is x squared y cubed to the 1/2. And I could pull that 1/2 out, but I think I'm going to go ahead and just take the top to the 1/2, and that would be x. It's actually the absolute value of x. Without the absolute value, I would be okay with that, but it's actually the absolute value of that. And then y to the 3/2. If you don't have the absolute value there, I'm fine. And now we can separate that into ln x, absolute value. And now it starts to make a little bit of sense. That has to be positive, but that's okay. It's going to be positive. So if you didn't have the absolute value, again, that's a discussion for another day. Minus ln y to the 3/2. I can't simplify that argument, but this argument, I could rule 3 this and pull that 3/2 out in front. Okay. And then these, a lot of times I'll just do these things in one step. If you have a factor in the top, the factors in the top become plus terms when we expand. The factors in the denominator become minus terms. So this just becomes ln x plus ln y minus ln z. As an example, it's worth noting, if I had ln, let's go a on bc, that would become ln a minus ln b and minus ln c, the factors in the bottom. You could do this. You could go, okay, it's ln a minus ln bc. And then we might be tempted to say it's ln a minus, well, how do we handle this? That would be ln b plus ln c, but it's minus all of that. The minus would distribute, and there we have it. Okay, how about this? In my head, I'm thinking of this guy as x to the 1/2. So this would break out into log base b, x to the 1/2, plus, it's in the top, it's a factor in the top, plus log base b, y to the 4th, minus, it's in the bottom, log base b, z to the 4th. Simplify the arguments, rule 3, 1/2 log base b x plus 4 log base b y minus 4 log base b z. Okay, so that is a appendage. I'll be redoing this video to have one all correct, but for our purposes in 2017, we're going to deal with it in 2 separate. There's another page before this and another page after this. Apologies if you went to the first video and we're missing that second page of notes.